Bismillahirrahmanirrahim. Welcome back to my channel. This video I'm very excited about. I've been wanting to make this video for a while, and the idea of this video definitely is going to be on GnuRadio companion. And the idea regarding this particular video is to understand what cognitive radios are. So I just have this website. I just want to read out the definition. Cognitive radios basically are smarter radios that actually build upon software-defined radios. So the idea was, like, I think the term cognitive radio was actually coined back in 2000, and it's the radio that can be programmed and configured dynamically to use the best channel in its vicinity to avoid user interference and congestion. So this type of radio will have a capability to actually detect signals automatically. At the same time, it will check the spectrum, if the spectrum has any activity or not, and based on that spectrum activity, it either is going to transmit or either is going to receive that signal. So the only possible way that we can practically implement cognitive radios that I know of is actually to understand software-defined radio. So the cool thing about this is that I love Linux because in Linux, when it comes to GnuRadio, you can compile these out-of-tree modules which are there, and someone has probably already worked on it or something like that, and then you can easily compile them, at least in Linux, as compared to any other distribution, for example Windows. And there's an out-of-tree module that I was experimenting with that is known as GR Inspector. So this particular GR Inspector, someone has made these blocks, and it will have some analysis block, some conditioning block, and then you have some GUI block. So what this particular flow graph is doing, it is exactly doing the same thing. It is actually performing signal analysis based on the signal strength to determine, okay, if that particular signal that I want, is that what I want? Is this a is this the actual signal that I'm looking for, and things like that. So it has, under conditioning block, it has a block called Signal Detector. So if you were to just simply bring that block out from that GR Inspector. So GR Inspector is actually an out-of-tree module that you have to compile it. I don't know if it's there in Windows or not. Definitely the version that I'm using in my Mac is not there, so that's why I'm using Linux PC. So when you install GnuRadio 3.10, it actually comes pre-compiled with it. So right now I'm using Dragon OS Focal that comes pre-compiled with GnuRadio, and I haven't done anything to this block except for one thing. It's just to set the threshold value. So basically the threshold value is, this is the threshold that I want. Anything less than or above than that, I don't want. That's what the threshold value is. Alright, so this is the minimum threshold that I have, and based on that, any signal that will come into that threshold, detect that signal and tell me what is that signal is. So it's automatically performing all of that for you. Plus it comes with a GUI inspector that actually gives you that. So it's sort of like an FFT sync, but this is dedicated for that GR Inspector block, GR Inspector out-of-tree module, and that's it. And by using, so you can always build upon someone else's work, and then you can always try to improve that work. So these blocks, instead of you making it yourself and then programming it yourself using C++ or using a Python wrapper, you can just simply use the already built-in block, and then you can design your radio based on these already available block. Conditioning block has signal detector, signal extractor, signal separator. You have inspector sync and things like that. So basically, we're just gonna actually use our RTL dongle, which I have connected to my laptop. You probably cannot see it, but it is, because I'm using an RTL SDR source. It is going into a throttle block, and then it's going to a signal detector block. Everything is as is. Instead of, I just change the FFT length to 4096. Everything is as is. Anything that is underline, you can change it using a GUI range slider. and this threshold value is set. That threshold value that I have set here on that GUI range block is from negative, so default value is negative 65 dB and negative 120 starting, and then going all the way up to 50 dB. Of course, the higher the number is, the stronger the signal is. Then it's going into that, this is the value of your threshold block. Everything remains the same. I haven't played around with that. And then next block is to use a GUI inspector. Nothing has changed. Instead of center frequency, I have just written down a frequency of an FM signal, which is 101.66 or 101.6 or 7. So I'll be able to visualize that particular frequency. Nothing else. The units are in hertz. You can do it in megahertz if you want. Let's try doing megahertz. And then there's a message debug block, so I can see the message that is going to pop up here. I couldn't make sense of most of what's coming in, but it's just there. So let me just disable this. So what this flow graph will do, it will actually, since my RTL SDR dongle is connected, it's going to tune into a frequency of FM signal, and based on the sample rate, whatever the signal window that you're seeing, all the signal that you will see, it will automatically detect those signals, and based on the threshold value, it will actually show me the signal and what is the frequency of that signal. So let's just quickly run this flow graph so you know. This is an amazing. I was actually looking for something like that because I've been wanting to do it for a while, that to application of cognitive radios, and this is like one of the most basic thing that you can do. Based on the value of signal strength, my flow graph will automatically detect what signal and what frequency is that. So this is something that is done automatically by the radio itself, so which is amazing. At least I find this to be amazing. So let me just run this flow graph. Here we go. I think there's so all the signals that you're seeing, let me just make it bigger. This is what you're seeing right now. There's a manual button. You can just do it yourself. Move this around, move this thing around, and then based on that you can just see what are the signals. This is normally what we do. We looked at a signal, the signal that has a higher strength, we try to look for that particular signal, and then we will see, okay, this is probably the desirable signal. By setting a threshold to -65, or you can just move around this threshold, and you can do it automatically. Remove this thing, and this, as you can see, these red lines, they are moving along on a signal strength, and based on those signal strength, because I have a threshold that is being set to -65, now it's actually looking at any signal that is around that range. So I can increase this threshold, sorry, decrease it, which means look for only stronger signal, and all of a sudden these lines will just, like, you know, these lines are reduced. Now let's say I was right here -64, so any signal that is somewhere around -64 dB, you start seeing it, you will start seeing more lines. Now anything more than that, which means you start seeing less and less signal, it will only look for a stronger signal. Sorry, right here, here we go. So there are only two signals that is qualifying to be at around -60 dB of threshold. That is this signal. I can decrease this, and I start seeing more and more of these signals. So this is sort of like automatic detection of your live signal that you're seeing, that is at around frequency range of your FM. And then you can just play around with this flow graph, and then you can do a live signal detection and also try to hear those signal as well. So this is somewhere around in a range of FM. Just simply close this, and let me just change this frequency to, let me go here and change this to 935 megahertz. This is somewhere around GSM signal. So it will, let's try to detect this, and let's make one more change here at 935 megahertz. Cancel. I don't want to, let me just go here, 935. Let me change these units. I think I've already changed these units. Apply mega. Alright, why is not changing actually? Alright, let me just hit play. Now I started visualizing signal strength that are from 935 megahertz. So these are the frequency ranges of your GSM signal that I'm seeing right now. And of course I can either decrease my threshold or increase my threshold, so I can start seeing lesser and lesser signal. The only signal that I'll be able to see at -56 threshold is about this, unless I move this antenna and I start seeing something else. So that's the beautiful idea regarding cognitive radios are. And I don't know if, because software defined radio is actually the building block of making cognitive radios possible. So I hope you like this small tutorial on this. In future I'll be exploring this more. I'll be exploring some of the examples which is available in GR Inspector, and I will try to actually share it with you guys, and I'll try to do a live demodulation using signal detection, signal extraction, signal separator block, and try to see that if we'll be able to understand how to see what FM signals are and things like that. We're just experimenting on different signals. So I hope you like the small tutorial. Thanks for watching, and don't forget to like and subscribe to my channel.